Okay, so to this point, right, we've done area of parallelograms, we've done area of triangles, now we're extending that to area of trapezoids. So, again, by definition, just a reminder what a trapezoid is. It means it's going to have one pair of parallel sides. So a quadrilateral with one pair of parallel sides is the definition of what a trapezoid is going to be. So before we get into the formula for how to find the area of a trapezoid, it can look a little bit more intimidating than say the formula for area of a triangle or area of a parallelogram, but still it's a formula and we can just utilize that. We're going to find the area of some trapezoids by decomposing the trapezoid. So splitting it up into parallelograms, splitting it up into triangles, things that we already have a formula for how to find the area. So that's an option we can utilize too, right? As opposed to using that whole trapezoid formula if we're given that information. So of course we're going to show our work in those things. So on A, when I look at that trapezoid, I notice that if I was to draw a line going vertically from one base to the other base here on this right side, that then I would have a rectangle here and a triangle here. And I know how to find the area of both of those things. So I'm going to break it up like that, combine the two areas together, and it'll give me the entire area. So first of all, starting off with the area of that rectangle. Remember, rectangles, it's base times height, or length times width. It's a parallelogram, right? My height is 7, my base is 8, so I'm going to take 7 times 8. So the area of that rectangle is 56. Now moving on to the triangle, I needed the height for the triangle, so that's 7. I can tell it's 7 by looking over there. Now, to get the base, I need to know what this right here is, right? The base is what runs perpendicular to the height. So right here, that forms a right angle. So I need to know what this measurement is. They don't tell me what that measurement is, but I know from here to here is 12. I know also from here to here is 8. So whatever's left over here needs to be, if I was to take this plus 8 needs to equal 12. So what plus 8 equals 12? Well, it's 4. So that tells me the base length of that triangle would be 4. So to get the area of that, right, I take my base, so 4 times the height, which is 7. And of course it's a triangle, so I'm going to be dividing it by 2. So 4 times 7 is 28, divided by 2 is 14. Again, that's the area of each individual piece. I wanted to put it together to get the area of the entire trapezoid. So I'm going to add those two together. So 56 plus 14. So that area is going to be 70. And since this is my final answer, I'm going to put a label on it. It was inches squared. Okay, B again, same thing. We're going to break it up into parallelograms here and triangles. Now this one, this would have been called an isosceles trapezoid. This one here is going to be called an isosceles trapezoid. This one would have been a right trapezoid. So it's going to split up a little bit differently. So if you notice here, I already kind of got those dotted lines in there. We've got a parallelogram here in the middle, and then we've got two triangles there on the sides, okay? So starting out again with the parallelogram there in the middle, base times height, that looks like I got 9 times 6. 9 times 6 is going to give me 54. Then looking at the triangle, so again, I need to know what the base is. So the base and the height are what form that right angle. So it looks like 4 for a base, 9 for a height. One thing I do notice, that this other triangle is identical, it's congruent. So it's also 4 and 9 also for the base and height. So I'm going to go ahead and do 4 times 9, divide by 2 because it's a triangle. 4 times 9 is 36, divided by 2 is 18. But again, those two triangles were identical, so I'm just going to times by 2, which puts me back at 36. Now you might say, well, did I really have to divide by 2 there since I was going to end up timesing by 2? That's right. I'm still showing it just because it was a triangle, and that's how I find the area of a triangle. But if you realize later, you're going to have to times by 2, you know. And then I need to add these together, right, to get the total area. So 54 plus 36, I get that it's 90 centimeters. Yes, centimeters squared. Okay, so moving on to example 2. Now it just says to find the area of the trapezoid. So the anticipation here is that I actually use that trapezoid formula. Now, depending on the information that they gave me, if I forgot what the area of trapezoid formula was, but I remembered how to find the area of a triangle and a parallelogram, could I do these the way I did those? Yeah, I could, okay? Sometimes maybe information-wise you don't have enough information to be able to do that. that would be really your only limitation there. But so what is the formula for area of a trapezoid? I don't have a lot of space here, so I'll kind of write it down here. So it's going to be a lot like the formula for a triangle. Okay, so we're going to have that divide by 2 in there. We're going to be doing something with the height. So it's going to be the height times the quantity. This is where it looks a little different. The parallel sides, which we call base 1 and base 2, added together, and base 1 and base 2 are always just the parallel sides. That's what they are. And then that divided by 2. So really it's identical to the triangle formula, except this part looks a little different. Rather than just taking the base times the height, I add together those bases and then times by the height and divide by 2. Of course, remember order of operations. I'm going to have to add those together first before I times by the height and divide by 2. And again, these two numbers right here are the parallel sides. Whatever the sides are that run parallel to each other, that's what the base 1 and base 2 are going to be. Okay, so that's how I know which ones they are, and then how I know what is the height. Okay, so then now moving on to applying that. So on example 2A there, find the area of that trapezoid. I notice, okay, 8 yards is these two sides right here running parallel to each other. So that means these are my bases. So 8 yards will be one of my bases. 5 yards will be one of my bases. It doesn't matter which one I call 1, which one I call 2. It's just referencing those are my parallel sides. 4, of course, then runs perpendicular between my two bases. Between those two parallel sides, that's how my height is going to run, so that's my height. And just a matter of plugging into the formula. So I'm going to kind of box this off so I can emphasize there that that's the formula. So then to get area, I'm going to take my height, so 4 times my bases added together. So that was 8 and 5 divided by 2. Okay, so again, order of operations, I take 8 plus 5 first, right? That's going to give me 13 times that by the 4. I'm going to divide by 2. I'm not going to show all of that work. You can kind of see it there in the formula. But that's going to give me an answer of 26. And of course, it was yards squared because area is always squared. Okay, next one there. Again, this had been what we call a right trapezoid. This is an isosceles trapezoid. I start by noticing, well, it is a trapezoid. The 12 and the 18, those are my parallel sides. Okay, they run parallel to each other, so those are my bases. So to get my area, I'm going to take my height, which runs a vertical from one base to the other, so 10, times my bases added together, so 12 plus 18, divided by 2. So 12 plus 18, 30, times by 10, divide by 2. I'm going to get 150 kilometers squared. Okay. Example 3 says the side of a bookend shown resembles a trapezoid. What's the approximate area of the side of the bookend? So again, just really asking me to find area. I recognize that, yeah, it is a trapezoid. They told me it was a trapezoid. It's turned a little bit differently. That doesn't matter. I still recognize what are the sides that are running parallel to each other. Well, that's the 5, that's the 4. So those are my bases. That's the base 1, that's the base 2. And the height is always going to run perpendicular from one base to the other base. And so that means the 6 must be the height. So all I need to do is plug into my area formula. So my height is 6. The bases are 5 and 4. So 5 plus 4 divided by 2. I'm going to get the area of this bookend, right? So 5 plus 4, 9. 9 times 6, 54 divided by 2. I'm going to get 27 inches squared. So I guess since it is kind of more a word problem, I should probably insert a sentence. So the bookend is 27 inches squared. Okay. Now, of course, example 4, like what we've had in our other ones with triangles, parallelograms, we're going to be a work backwards type one, where we know the area, but we're trying to figure out what one of our missing measurements is. Okay. So in this one, I'm given that the area is 56, and I'm just going to kind of start plugging stuff into my formula. So my formula is always area equals, right? So I know the A is 56. Then I usually have height, right? I don't know what the height is. Now, they did label the height as B, which can be a little confusing, but these here would be my bases. But I'm going to put a B here for the H because they said that this was my height, that B was my height, so that's why I'm using a B instead of an H. I know what my parallel sides are. they're the 6 and the 8, so 6 plus 8. And then again, I know I always do that divided by 2, right? And I'm just going to kind of start working through that formula, and I'm going to start working backwards. Now, I can take 6 plus 8 inside there, right? I can do that. That's going to give me 14. So I'm going to be left with b times 14 divided by 2. At this point in time, I start saying, well, now I need to start looking at working backwards, right? So right now, this is all being divided by 2. The opposite of that, the inverse, would be to times both sides by 2, right? To get rid of that divide by 2 so I can figure out what the height was. So 56 times 2 is 112. It gives me b times 14 left. And then again, what's the opposite of taking 14 times my height, also referenced as b here, would be to divide both sides by 14. And that's going to give me that the b, the height in this problem, 112 divided by 14 is going to end up equaling 8. Again, my label on this, it is not area. I only put the squared right when it's area. So my label is just going to be 8 feet. And I've got my answer.